In today's lecture, we will discuss about the retarded potentials and Leonard-Wishart potentials. So before starting the retarded potential, let us we understand the fundamental meaning of vector and scalar potentials. These are the electromagnetic potential, you all know, and they represent respectively the vector field and the scalar field. So the vector potential is defined as that this is such a potential whose curl basically gives us the magnetic field. So if a vector is a vector potential, means this is the potential due to the charge particle which is present in the given volume, and due to that charge particle there is a vector field there. So the curl of this vector potential gives the magnetic field. So the relationship between B and A is B equals to curl of A. So here A is the vector potential and B is the magnetic field. So whenever we take any vector quantity or a vector field, so its curl will give us the magnetic field. And if suppose we have a scalar quantity like pressure or potential energy or gravitational energy, so its negative gradient gives us the vector quantity, and that may be force or electric field. So basically the negative gradient of the scalar quantity, it gives us the vector quantity, and this is called the scalar potential. So the scalar potential basically describe the situation when when there is a difference between two potential energy of an object at different position. So the difference in the potential energy here, it does not depend upon the path, but it depend upon the position actually. So means कहने का मतलब है कि the difference, suppose the potential at this point is VA and the potential is at point B is VB, the distance between them is x here. So the potential is here changing with respect to position. So that is in mathematical term, we will write down it dV by dx. So when there is a change in the potential with respect to position, then it gives us the scalar potential. So here change in potential causes a field, and that field is basically a vector field. So we have three types of relations. If we see in hydrodynamics, so you know that in hydrodynamics, if suppose P is pressure, so its negative gradient gives us force. So F equals to minus grade P. If we are talking about the gravitational field and U is the gravitational potential energy, so its a negative gradient gives us the force. So F equals to minus grade U. And in the electromagnetic field theory, if phi is the scalar potential, so its negative gradient gives us the electric field. So these are the three examples in hydrodynamic, gravitational media, and in electromagnetic field. Okay. So gradient, scalar field, and its a physical significance. I know it is a very basic quantity you learn at your undergraduate level. So basically these represent here the change in potential with respect to position. So change in potential with respect to position causes a field, and that is called the scalar potential here. So these are the basic potential basically, and we will focus on the electromagnetic potential. So we have two quantity, capital A, which is vector potential, and phi, that is scalar potential. So in classical electrodynamics, we all know that A and phi, and how this A and phi they are related with B and E, that is electric and magnetic field, and their relationship can be also obtained. So if we take the basic equations of electrostatic and magnetostatic, so I am here talking about the electrostatic and magnetostatic case, okay, not electrodynamics case. Means I am talking about the stationary states here. Stationary states are those states which are time independent. So that is, the charge particle is fixed, not moving. So all the time derivative in the Maxwell equation will become 0. So our Maxwell's equation will become here. The Gauss law will become divergence of E equals to rho by epsilon naught. The Faraday law becomes curl of E equals to 0. There is a minus dou B over dou T term, but we are talking about the electrostatic case and magnetostatic case. So both time derivative term will be here 0. So the second equation will remain as it is, divergence of B equals to 0, and these two equation will give us curl of E equal to 0 and curl of B equals to mu 0 j plus epsilon 0 mu 0 dou E over dou T term will become 0 for the static case. So in the electrostatic and magnetostatic case, let us we try to find out the uh, electromagnetic potentials. So we, from this equation number third, you can clearly see that if curl of E equals to 0, so according to the definition of E rotational vector, we know that if curl of a vector field is 0, so it represents a E rotational vector. Okay, that is, you cannot uh, discuss the rotational symmetry of that vector. Means here all the changes in this E with respect to either x, either y or z, it will give us 0. So that is called E rotational. So basically curl shows the rotational property, and if curl of a vector is 0, that is, it is a E rotational quantity. So if it is a irrotational quantity, so there is a very simple vector algebra that this field can be written as a negative gradient of a scalar field. So E can be represented as negative gradient of scalar field V, where V is the electrostatic potential here. If you put here E equals to minus grad V, so from the vector property, curl of gradient of a scalar field is always 0. So that is satisfied. Okay. So from here, we get a potential V here. So that is the electrostatic potential. And equation number 1, it gives us here, if you put here this value E equals to minus grad V, so we get minus delta square V equals to 1 by rho 0, 1 by epsilon 0 rho. So this is called the Poisson equation. Poisson equation in terms of gravitation, in terms of electrostatic potential. Okay. So these two relations are basically uh, obtained with the help of these equations, which are strictly valid only for the electrostatic and magnetostatic case. So this is for the electric field. Now see, we have the relation B equals to curl of A. If we put the value of B here in the fourth equation, so we will get curl of A equals to mu 0 j. Okay. Now apply here the vector property, curl of a vector. So curl of a vector is written as gradient of divergence of that vector minus divergence of gradient of that vector. So divergence of gradient of that vector हो जाएगा डेल्टा स्क्वायर ए. तो ये इसका फॉर्मूला है, कर्ल ऑफ ए वेक्टर इक्वल्स टू दिस. ओके. Now if suppose divergence of A equals to 0, why this is 0? It is a specific condition which is called the Lorentz gauge. अभी हम उसको डिस्कस करने जा रहे हैं. So if suppose divergence of A equals to 0, if A vector is a vector potential and its divergence is 0, then this term will become minus delta square A equals to mu 0 j. फाइनली आपको मिल जाएगा यहाँ पे सेम इक्वेशन जैसे यहाँ मिला आपको स्केलर पोटेंशियल V के लिए इन टर्म्स ऑफ J, ऐसे यहाँ पर आपको वेक्टर पोटेंशियल के लिए इक्वेशन मिली इन टर्म्स ऑफ J. ओके. नाउ व्हाट इज दिस, what is the significance of these two equations and why we have put this divergence of A equals to 0? इसको मैं अभी लॉरेंट्ज गेज बताऊंगा, वहां आप समझाऊंगा. Okay. So how we do express these electromagnetic fields in terms of electromagnetic potentials. Okay. And what happens to the Maxwell's fundamental equations, these equations. when we substitute the value of the relationship B equals to curl of A and D equals to minus grade V. Okay. So let us we now change our Maxwell equation in terms of electromagnetic potential. So if you put in Faraday law, and I am taking the original equations, okay, for the electromagnetic part, for the electrodynamic part. So we are taking the fundamental equations. ये तो सारा electrostatic case हुआ, but this is not of our use because these all are valid for a static charge. We are talking about the electrodynamics. So that is the particle is moving. So the time varying term will not be equal to zero. So the question is that in that case, when a charged particle is moving, so what are the potentials associated with a moving charged particle? For the electrostatic case, these are the potential. These are the second order differential equation. Their solution will give us the vector and scalar potential. But what happens to the case when the charged particle is moving? So that we can easily derive with the help of the basic equations. So if you take Faraday equation first, curl of E equals to minus dou B over dou T. Put here B equals to curl of A. Now here space and time derivative, they can be changed. So we can write down curl of minus dou A over dou T, and then take this whole term here and take common this curl. So you will get curl of E plus dou A over dou T equals to 0. Again, earlier there was curl of uh, here there was curl of E equals to 0. So you have written E equals to minus grade V. Similarly here curl of this quantity is 0. So this quantity, whole quantity can be written as a negative gradient of scalar field. So we are writing here E plus dou A over dou T equals to minus grade V. So in this way you will get E equals to minus grade V minus dou A over dou T. So this relation gives you the relationship between vector potential A and magnetic field, and this gives the relationship between electric field and scalar potential V and vector potential A. Okay. So these are the correct relationship for a moving charge particle. And now what happens to the Maxwell equation now? Let us see. So equation first again, we have divergence of E equals to 1 by rho 0 epsilon 0 rho. Substitute here the value of E, that is this, minus grade V minus dou A over dou T. If you substitute here again, so see here, you have one additional term here. If we put this term divergence of A equal to 0, which is called here the Lorentz gauge. So if we use the Lorentz gauge, so divergence of A equals to 0 रखें, तो again हमें previous condition आ जाती है. Or if we talk about the electrostatic case, so time varying term को अगर हम हटा दें, तो again हमें previous equation आ जाएगी, Poisson equation ये वाली. Okay. Now again, if you put here the relationship of B in terms of A here in the curl Ampere's law, Ampere's modified Maxwell modified Ampere law, that is fourth equation of Maxwell. So if we put here B equals to curl of A, तो ये हो गया curl of A equals to this, and E again substitute here the value of E, that is minus grade V minus dou A over dou T. So you will get this two term here, this two term, okay, and we can further substitute the value of this delta square V plus dou A over dou T equals to minus 1 by epsilon 0 rho. यहाँ पर again definition लगाई, curl of a vector equals to that minus gradient of divergence of A minus delta square A. इसको लॉरेंज गेज यूज किया हमने, तो जीरो हो गई टर्म. तो फाइनली ये इक्वेशन, इस इक्वेशन को जब सॉल्व करें तो ये इक्वेशन हमें मिली फाइनली यहाँ पर. ओके. सो दिस इज द मैक्सवेल इक्वेशन इन टर्म्स ऑफ वेक्टर पोटेंशियल एंड स्केलर पोटेंशियल. दिस इज द मैक्सवेल इक्वेशन इन टर्म्स ऑफ वेक्टर पोटेंशियल एंड स्केलर पोटेंशियल. तो बहुत सारी जगह इन इक्वेशंस की जरूरत पड़ती है हमें. तो अगर आप you want to discuss the Maxwell equation in terms of electromagnetic potential, so these are basically the equations. Okay. Now let us take one example how to calculate this. There is one problem I am taking here, that suppose the vector and scalar potentials, they are defined such that v equals to 0 and a equals to mu 0 k by 4c ct minus mod x whole square z k for x less than ct, and for x greater than ct a is 0. So this is a vector potential which is defined as this. K is wave number here, c is speed of light, and t is time. Okay, x is position. तो स्केलर पोटेंशियल जीरो है एंड वेक्टर पोटेंशियल डिफाइन कर रखा है, यहाँ पे दे रखा है. तो वी हैव टू कैलकुलेट द चार्ज एंड करंट डिस्ट्रीब्यूशन. चार्ज मीन्स वी हैव टू कैलकुलेट रो एंड करंट डिस्ट्रीब्यूशन, दैट इज जे और करंट डेंसिटी. ठीक है, करंट फ्लोइंग पर यूनिट एरिया, so that is called current density or current distribution. So since we have the relationship between rho and a from this relation, this is the relation, we have the relationship between rho and a, so we can use here that relationship. Okay, so see here, I am taking this equation. So since v equals to 0, it is given here, so put v equals to 0. So this equation becomes minus dou over dou t of divergence of a equals to 1 by rho epsilon 0 rho. So what will be the value of rho? Rho equals to minus epsilon naught dou over dou t of divergence of a. And similarly, from this equation, put here v equals to 0. So this term will become 0 here. So you will get the value of j equals to minus 1 by epsilon 0 this. Okay, so this is the value of j. Now how this comes 0? मैंने अभी substitute किया था divergence of a equals to 0. Divergence of a, if we find out here, so this will give us three terms. If ax, ay, az are the three components of vector potential, so dou ax over dou x, dou ay over dou y, dou az over dou z. Okay, so if we differentiate, means if we differentiate here this condition, just differentiate it. Okay, and if we differentiate this with respect to x first. Okay, so this is since x vector, so we have only z component. Okay, here there is no any x component, so this term is 0. There is no any y component, so this is 0. So there is only z component. Now if you differentiate this with respect to z, तो हमें मिलेगा dou az over dou z. But here there is no any z term. Okay, there is no any z, so means this is constant with respect to z. So if you differentiate this with respect to z, so it will be also 0 because there is no any z, only x is there. Okay, तो जो होल टर्म हो गई आपकी डाइवर्जेंस ऑफ ए इक्वल्स टू 0 हो गया. अब अगर आप इसको डबल डिफरेंशिएट किया हमने, सो डबल डिफरेंशिएशन ऑफ दिस, जस्ट so the double differentiation of a will be Laplacian of az zk. Okay, Laplacian of az zk, if we differentiate this with respect to twice with respect to z, so I think there is some mistake in this solution. I think how they have calculated. Okay, so let us you try to solve this first, then I will explain you. So finally they are getting, इसको differentiate करिएगा जरा दो बार यहाँ पे इसको रख करके x के रिस्पेक्ट में, और y तो है ही नहीं यहाँ पे, और z भी नहीं है, बट यहाँ पर as it is लिखा है. तो I think ये इसको सॉल्व करिएगा जरा. बट फाइनली they are getting delta square A equals to this, and this quantity also equals to this, both are same. So finally if you put here this value and this value and divergence of A 0, so J is also 0. Okay, for this case. So this is a homework for you, इसको जरा differentiate करिएगा. I will send you the PDF file. So both rho and J are 0. Means here the volume charge density rho and the current density both are 0 here. So if both are 0, so from where the electric and magnetic field comes? If there is no any rho means here it is the source for the electric field. Rho is called the volume charge density, that is number of charges present per unit volume. अगर चार्जेस है ही नहीं तो इलेक्ट्रिक फील्ड कहाँ से आ रहा है? इफ देयर इज करंट डेंसिटी जीरो, अगर करंट डेंसिटी J जीरो है, देन मैग्नेटिक फील्ड कहाँ से आ रहा है? So the reason is that space charge. The reason of having electric and magnetic field here, it is the space charge. Okay, so they might originate from the surface charge or surface current. So that if we calculate here E using the relation E equals to minus dou over dou T of divergence of A minus grade phi minus grade V term 0 हो गई because V 0 हुआ. So now let us we calculate electric and magnetic field. So electric and magnetic field we can calculate using this relation, E equals to minus grade V minus dou A over dou T, and magnetic field we can calculate using curl of A equals to 0. So if we do this, so after solving we get electric field E equals to this, which is non-zero term, and magnetic field B equals to this, which is also non-zero. So these electric and magnetic fields are basically produced due to the surface charge or surface current. So surface charge or surface current are basically the current produced due to the charged particles which are exist on the given surface. Okay. So using this fundamental relation, if there is a charged particle, there will be vector potential which gives you the electric field, and that gives you the magnetic field also. So this is the one of the reason. Okay. Now let us come to the gauge transformation. Gauge transformation is very important in the case of electrodynamics. So earlier we have 6 components of electric and magnetic field in the Maxwell equation, and we have reduced these 4 equation into 2 equation in terms of vector and scalar potential V and A. Okay, so we are now free to impose extra conditions on V and A as long as nothing happens to E and B. So you can add other conditions on this V and A if there is no any change in the electric and magnetic field. So this is just like that we give some small displacement to a particle, so its a displacement become x plus dx. So doing that, so if there is no any change in the fundamental quantity, then it is termed as the gauge transformation. So gauge transformations are especially for the electromagnetic potentials. So how we find the gauge transformation for the electromagnetic potential? Let us see. Suppose we have two set of potential, VA and V prime A prime. Means at suppose any point the potentials scalar and vector are V and A, and on the other point the potentials are V prime and A prime. Okay? And this corresponds to this two relation. So I am here slightly changing this potential. Means जो potential आपका एक position पर A है, दूसरी position पर कोई different potential है. Suppose that changes alpha, and they are related with this relation. A prime equals to A plus alpha. Means the potential at point B is suppose A plus alpha. Similarly, the potential at vector scalar potential at point B is suppose V plus beta. So there is a small increment in this potential. Okay, so we have two potential V and A at a point. particular point A, and at another point we have two potential such that. Now let us try to find out the relationship between these two potential. See, we have B equals to curl of A. This is the fundamental relation. Now put here the value of B. Uh, if you put here the if you put here the value of um, a here, so A will become here A prime minus alpha. So you will get here two terms. Okay. So B equals to curl of A, and if you put here the value of A, so you will get two terms. Curl of A prime minus curl of alpha. Okay. So curl of A prime equals to implies that कर्ल ऑफ अल्फा, तो दोनों टर्म यहाँ पे सेम आएगी. b इक्वल्स टू कर्ल ऑफ ए है एंड दैट इज इक्वल्स टू कर्ल ऑफ ए प्राइम. ओके, एंड another term will be curl of a. Since both term are same here, curl of b and curl of a, so it will be cancelled out and you will get curl of alpha equals to 0. ओके, इसको सॉल्व करिएगा ए प्राइम की वैल्यू यहाँ रख के, तो दोनों साइड से कैंसिल हो जाएगा कर्ल ऑफ ए टर्म कर्ल ऑफ ए टर्म, तो यू विल गेट कर्ल ऑफ अल्फा इक्वल्स टू 0. या सीधा सीधा यहाँ पे रखिए, आप देखिए कर्ल ऑफ इसका दोनों साइड का कर्ल ले लीजिए. सो कर्ल ऑफ ए प्राइम इक्वल्स टू कर्ल ऑफ ए प्लस कर्ल ऑफ अल्फा. कर्ल ऑफ ए इज इक्वल्स टू कर्ल ऑफ ए प्राइम. अभी हमने यहाँ लिखा है कि यू can do the change in the vector potential such that there is no any change in the conditions. So means curl of a prime will be equals to curl of a. तो जब आप यहाँ पे कर्ल ऑफ ए प्राइम किया इक्वल्स टू कर्ल ऑफ ए प्लस कर्ल ऑफ एल्फा, so both are same, so both will be cancelled and only you will get कर्ल ऑफ एल्फा equals to 0. So this is the meaning of gauge here. समझिए यहाँ पे you have changed the potential, but due to that there must not be any change in the fields, means B must remain same even though if you are changing the potential. So that's why our B was curl of A and हमने यहाँ पे A prime slightly change किया potential को, so you will get curl of alpha equals to 0. Again curl of alpha is 0, that is alpha can be written as a gradient of this scalar function. Similarly E इक्वल्स टू माइनस ग्रेड V माइनस डो ए और डो टी. यहाँ पे हमने चेंज किया V को V प्राइम, ये रिलेशन लिया हमने V प्राइम और A प्राइम के लिए. नाउ सब्स्टिट्यूट द वैल्यू ऑफ V प्राइम that is V plus beta and A prime that is A plus alpha. You will get this term and some same term will be this is basically E minus grade V minus dou A over dou T. This is E. So this E and this E will be cancelled. So you will get minus grade beta plus dou alpha over dou T equals to 0. That is, if this is 0, so you can again write down this as a and substituting the value of alpha equals to grade lambda, okay, and taking grade common. So gradient of this quantity is 0, that is this quantity is a constant quantity. So beta plus dou lambda over dou t equals to a constant, suppose kt. तो ये हमें देगा ये रिलेशन ग्रेड ऑफ बी बीटा प्लस डो over dou t of lambda equals to 0. If this is 0 means this quantity is a constant. So suppose this is kt. तो बीटा की वैल्यू क्या मिली हमें, kt minus dou lambda over dou t. So this is alpha, that is alpha equals to delta lambda equals to delta lambda prime and beta equals to minus dou lambda over dou t plus kt. Okay, and let this is equals to minus dou lambda prime over dou t. तो अब ये अल्फा बीटा अगर आप यहाँ रख दो जो अपने गेज ट्रांसफॉर्मेशन लिया हमने, सो अल्फा ए प्राइम इक्वल्स टू ए प्लस अल्फा, अल्फा की वैल्यू रख देंगे और वी प्राइम इक्वल्स टू वी प्लस बीटा. सो यू विल बी हैविंग दिस टू न्यू पोटेंशियल्स, ए प्राइम equals to a plus delta lambda and V prime equals to V minus dou lambda over dou t. So these are the small changes alpha and beta जो हमने अभी consider किया था. Okay, so these are the two parameter, and that parameter here shows the little change in the potential, and that is called the gauge transformation. So conclusion is what? That for any scalar function lambda, we can with impurity add delta lambda term to a, and it provide simultaneously we subtract the dou lambda or dou t from v such that there will be no any change or they will not affect electric and magnetic field. So this is called the gauge transformation, that you add or subtract something from electromagnetic potential. Because of that, there should not be any change in the electric and magnetic field. तो बेसिकली जब हम पढ़ते हैं आगे इलेक्ट्रोडायनेमिक्स तो सिर्फ ये रिलेशंस को यूज करते हैं. बहुत बार इट इज वेरी डिफिकल्ट टू अंडरस्टैंड कि ये टर्म कहाँ से ली हमने. बेसिकली दीज आर द ओरिजिन्स, दैट दीज आर द वेक्टर पोटेंशियल, दीज आर द गेज ट्रांसफॉर्मेशंस. तो जब भी आप पोटेंशियल के लिए गेज ट्रांसफॉर्मेशन लेंगे तो ये दो रिलेशन लेंगे. ठीक है. तो दो तरह के ट्रांसफॉर्मेशन होते हैं, गेज होते हैं. एक होता है कूलाम गेज और एक होता है लॉरेंज गेज. कूलाम गेज क्या होता है? दैट इफ सपोज वी अगेन टेक द इक्वेशन, our equation, first equation, divergence of E equals to minus 1 by rho 0, 1 by epsilon 0 rho. Put the value of E minus grade V minus dou A over dou T. तो वो इक्वेशन में ये मिली. और ऐसे ही फोर्थ इक्वेशन में अगर आप बी को रिप्लेस करेंगे कर्ल ऑफ ए से और ई को रिप्लेस करेंगे अगेन उसी रिलेशन से, तो ये दो इक्वेशन मिलती है जो अभी हमने यहाँ पर लिखी थी. ये यहाँ पर लिखी थी हमने ये इक्वेशन, दिस वन एंड दिस वन. सो इन दिस इक्वेशन दिस इज कॉल्ड द कूलॉम गेज. ओके, डाइवर्जेंस ऑफ ए इक्वल्स टू 0. और डाइवर्जेंस ऑफ ए इक्वल्स टू 0 ये ऑलवेज होता है जब इफ what is Coulomb gauge? If the vector potential A is such that it is always a diverging field, then it will be called the Coulomb gauge. So if divergence of A equals to 0, okay, we know that divergence of a vector field can be positive, negative or 0. So if it is 0, that is there is no any source, no any sink. So suppose किसी फील्ड में आपका वेक्टर पोटेंशियल ए इस तरह से है कि उसका डाइवर्जेंस 0 है, that is it is not a, that is it is a non diverging term suppose. So this is called the Coulomb gauge. So it depends upon type of potential. Sometime A is given such that इसका डाइवर्जेंस 0 हो आपका. So if you use this Coulomb gauge here, so we get the Poisson equation. If we put here this Coulomb gauge and the solution of this Poisson equation gives us the scalar potential V, and this is a second order differential equation. Its a standard solution is given by VRT equals to 1 by 4 pi epsilon 0 rho r prime t upon r d tau prime. यहाँ पर r prime जो है ये this is the position of the particle and this is r is the distance of the particle from the origin. Okay, and d tau prime is the volume element on that given surface. So the advantage is that using Coulomb gauge you can calculate the potential. अगर इस इक्वेशन में अगर आप Coulomb gauge यूज नहीं करेंगे so it will be little bit difficult to calculate V. But as soon as you put here divergence of A equals to 0, that is Coulomb gauge condition, you get a simple second order differential equation whose standard solution give you the scalar potential. But what is the disadvantage? The disadvantage is that even if you substitute here divergence of A equals to 0, that is if you use Coulomb gauge in this equation, so again there is a second order derivative of A here, time derivative of V, and to solve this equation is little bit difficult. So this is the one of the disadvantage of this equation, that on putting the Coulomb gauge we cannot calculate the vector potential A. So this equation is very typical one. It cannot be solved. Okay. So you can simply say here that the Coulomb gauge, and one of the limitation of the Coulomb gauge is that this Coulomb gauge is suitable for static case only. Means this is suitable for a charged particle who is in rest position. बिकॉज यहाँ देखिए अगर आपका डाइवर्जेंस ऑफ ए जीरो हुआ दैट इज फ्रॉम आवर रिलेशन बी इक्वल्स टू कर्ल ऑफ ए बी भी जीरो होगा आपका सो बी मीन्स देर इज नो एनी वेक्टर पोटेंशियल नो मैग्नेटिक फील्ड so that is the static case. So this is the limitation of the Coulomb gauge. In other terms, Lorentz gauge. Okay, in other words, if we see about the Lorentz gauge, so what is Lorentz gauge? We have again same two equations. Okay, अब पहली इक्वेशन में तो इजीली हमने अभी यहाँ कर दिया था, Coulomb गेज यूज किया तो ये हमको दे देगा स्केलर पोटेंशियल. अब इस इक्वेशन को सॉल्व करने के लिए ये टर्म जीरो होना बहुत जरूरी है. If this term whole term becomes zero, then we can calculate the vector potential. So if this term is zero, divergence of A plus mu naught epsilon naught dou V over dou T, if this is equals to zero, then this equation can be solved simply. How? If this is zero, तो ये टर्म जीरो हो गई, तो हमारा यहाँ पे अगर हम कॉमन ले ले ए वेक्टर को, वेक्टर पोटेंशियल को, तो ये आपकी इक्वेशन सिंपली आपको डीएलम्बर्शन ऑपरेटर मिल जाएगा. डेल्टा स्क्वायर माइनस म्यू नॉट एप्सिलॉन नॉट डो स्क्वायर और डो टी स्क्वायर, दिस बिकम डीएलम्बर्शन ऑपरेटर इक्वल्स टू माइनस म्यू जीरो जे. तो ये दो फंडामेंटल इक्वेशंस मिल गई आपको. ओके, दिस वन इक्वेशन इज इन टर्म्स ऑफ the potential, scalar potential, and another term is for the vector potential. So we can simply write down this equation is d'Alembert of V equals to minus 1 by epsilon naught rho, and d'Alembert of A equals to minus mu 0 j. So the use of Lorentz gauge is that we can easily transform our Maxwell equations in a simplified form that can be solved also to calculate the vector and scalar potential. So see, if simply I say, so Lorentz gauge is a just basic condition जिसको आप substitute करें इन equation में, तो we get a simplified form of the equations. तो ये meaning है Lorentz gauge और Coulomb gauge का, that putting Lorentz gauge condition we can get our Maxwell equation in terms of soluble condition, they can be solved. Okay, and the advantage of this Lorentz gauge is that we can solve the Maxwell inhomogeneous equation and we can get the vector and scalar potentials. Okay, तो अभी वेक्टर एंड स्केलर पोटेंशियल्स शुरू करने के पहले की ये पूरी थोड़ी हिस्ट्री अबाउट दी वेक्टर एंड स्केलर पोटेंशियल, हाउ we transform the vector and scalar potential using the Coulomb gauge and Lorentz gauge, and how basically these equations are obtained. So जब भी हम in these are called the Maxwell's inhomogeneous field equations in terms of scalar potential and vector potential. So here you have the field V, that is scalar potential. Here rho is the source. Source means this is the volume charge density. So because of charge you have the potential, because of current distribution you have the vector potential. So these are called the fields parameter and these are called the source parameter. So A and V, these are the field parameter and these are the source parameter. कहने का मतलब कि अगर कोई एक सरफेस है आपकी एस कहीं, यहाँ पर रो वॉल्यूम चार्ज डेंसिटी है, so because of this volume charge density, what will be the field at a particular point? So that gives this relation, Poisson equation. And similarly, if you have a current distribution on a surface J, so what will be the vector potential at certain point? So this gives this relation. So these two relations, finally, if I conclude how this comes, we have Maxwell's four fundamental equations in terms of electric magnetic field. हमने उसमें E और B को रिप्लेस किया A और V की टर्म में यूजिंग द रिलेशनशिप B इक्वल्स टू कर्ल ऑफ A. and E equals to minus grad V minus dou A over dou T. After putting Lorentz gauge, we get these two equations in this form, which are called the Maxwell's inhomogeneous field equation. तो हमारा रिटार्डेड पोटेंशियल की कहानी यहाँ से शुरू होती है. इसके पहले लेक्चर में मैंने इन दोनों इक्वेशंस को हमने 4 वेक्टर फॉर्म में भी ट्रांसफॉर्म कर लिया था. ओके, वहां पे हमने v को साई लिया था सिंबल. हियर आई एम टेकिंग v. ओके, सो दीज इक्वेशंस कैन बी transferable under Lorentz transformation, you know, and because this D'Alembert operator is invariant under Lorentz transformation, so this is best to use these equations in the 4-dimension case also. So these equations, they can be used appropriately in the case of relativistic electrodynamics. So now, if we talk about the non-relativistic case, so in non-relativistic case, A and V are the simple electromagnetic potential. But if the charged particle is moving relativistically, so what will be the electromagnetic potentials? So that potentials, that is the potential produced due to the moving or current moving charge or charge distribution, and where particle is especially relativistic one, so these are called the Liénard-Wiechert potential or LW potential. And the potential produced due to simply moving charge or current distribution, these are called retarded potential. तो दो नए वर्ड है आपके लिए यहाँ पे, रिटार्डेड पोटेंशियल एंड लिनार्ड विचार्ड पोटेंशियल. तो आई थिंक अब आज के लिए आपको ज़्यादा हो जाएगा, तो नेक्स्ट क्लास में मैं आपको लिनार्ड विचार्ड पोटेंशियल या रिटार्डेड पोटेंशियल को समझाऊंगा. एंड वी विल यूज विद द सेम इक्वेशंस जो अभी हमने यहाँ पे लिखी है, इनके सॉल्यूशंस जो हैं वो हमको एल डब्ल्यू पोटेंशियल्स देंगे यहाँ पर. सो फर्स्ट यू क्लियर दिस फंडामेंटल. अभी मैं आज आपको इसका पीडीएफ बना के भेज देता हूँ, इंक्लूडिंग दिस स्लाइड्स आल्सो. और कल हम या जो नेक्स्ट क्लास में जब लूंगा उसमें आपको आगे बताऊंगा रिटार्डेड पोटेंशियल्स आर एल डब्ल्यू पोटेंशियल्स. ओके, तो आज के लिए अभी इतना ही रखते हैं. ये 10 स्लाइड है आज की, 9 स्लाइड, इनको आप थोड़ा देखिएगा. अब बताइए, डाउट हो किसी को कुछ तो. इफ यू हैव एनी डाउट यू कैन आस्क. युष्मी साहू, युष्मी साहू, अनम्यूट योर सेल्फ. नहीं सुन रही, कहाँ गई? योगेश पटेल.